Hello everyone. So in the previous video we have discussed about the physical change. So let's give a quick revision to that. So physical change means a change in which the substance, size, shape or color is changed. But if we want, we can change the thing to the previous form, and these type of changes are known as physical changes. But the physical property of the substance gets changed, and deliberately it can be changed back to the previous form, and that is known as physical change. Now in this video we'll be discussing about chemical changes. So this is magnesium ribbon, one type of metal. Magnesium is a metal and is very soft metal. We can tear or we can break these magnesium metal with the help of our hands, and this is a very soft kind of metal, and it is found in the form of magnesium ribbon in the science shop where the science materials are present. So this magnesium ribbon, when it is present in the form of metal, and it shines, and it shows all the properties of the metal. And when we burn the magnesium metal, we burn the magnesium metal in presence of air, when we burn it, it appears like this. The color of the substance changes and it becomes like a powder. When we will crush these things, and it will convert into powder, and that is known as magnesium oxide powder. So magnesium changes to magnesium oxide because when we burn it, the magnesium reacts with the oxygen and it converts to the magnesium oxide form. So about magnesium oxide and burning and all the reactions we will be learning in the next classes, in the higher classes. Here we will just understand that the magnesium is a metal. When we burn it, it converts into magnesium oxide, which is a powder. So if we want, now can we change this powder to the previous form? Not possible, because the powder cannot be changed back to the previous metallic form. So it is not possible, and this is one example of chemical change. Here the chemical reaction is taking place between the magnesium and oxygen, and the things are changing completely, which cannot be brought back to the previous form. So this is one type of example of that our chemical changes. Then in the next one we have the copper sulphate, very important and very nice and very beautiful copper sulphate, which is blue in color and very attractive blue it is, and it is a salt. So copper sulphate is a salt. We cannot consume it because it is not the table salt that we eat, it is a different one. And in our chemistry we have hundreds of types of salts, and this is one type, copper sulphate, very famous salt. And this is the copper sulphate solution. So when this copper sulphate salt is added to the water and it is stirred, this gets converted to the copper sulphate solution. So the solution is also very beautiful and it is blue in color. And when we dip one iron nail, we all know what is iron nail. So when we will dip any iron objects, iron nail or any kind of iron object without rusted, or if we take one iron nail and if we dip it into the copper sulphate solution, and if we leave it for some time, like 4 hours, 5 hours, 1 day or 2 days or 1 week, what will happen? Here you can see, after some time, after 1 week, when we will take out the iron nail, we can observe two things here. One thing is that the portion which is dipped into the solution has a layer of something. So has a layer of something, and the color of the solution also has also been changed. So what are the things happen? So here one chemical reaction is taking place. The chemical reaction is between the iron and the copper sulphate. So here the portion which is the layer which has formed on the top of the iron nail is copper. So in the copper sulphate solution, copper is there, and that copper has this copper sulphate, or the copper from the copper sulphate solution has prepared a layer of copper on the top of the iron nail, and from the iron the iron nail, some portion of the iron has mixed with the sulfate solution of the copper sulfate solution. In the copper sulfate we have two parts, that is copper and sulfate, and copper has come here and the iron from this nail has mixed with the copper, and the solution is now is ferrous sulfate or iron sulfate. So we will not say that ferrous sulfate, we will say it is iron sulfate, because in class 7 we will not go in such detail. In higher classes you will get it. So iron sulfate, so from this one the iron portion or the iron from this iron nail will get mixed with the sulfate, and the solution is now will be called as iron sulfate solution, which is little greenish in color. So previously it was purely blue, and after that it has changed to little greenish. So when these type of things will occur, then it is known as chemical change, because we cannot change this to the previous form. Can we change to this one? If we dip it for some more time, will it be that? No, it is not possible. The previous form cannot be obtained, and these type of things are known as chemical changes. So here you can see the color, change the color of the solution. Previously it was like that, and after some time what happens, the solution has changed its color to the little greenish, and this is a chemical change. These things cannot be changed back to the previous form. Then rusting, another very important. Here you can see that this is the chain that we buy from the market. From when we buy it, it appears like this, pure metallic. It is in pure metal color, and when we use it for some days, when we leave it in the air for sometimes in open space, the things change to this color. Why it happens? Because when we leave it in open space in the atmosphere, so it happens because of the rust, or the process is known as rusting. So here what happens, when we leave the chain or any iron object in open space, in the atmosphere we have the water vapor and we have the oxygen, and these two things react vigorously with the things, and which after some times or after some days we can see that rust is there on the object that we have left on the open space. And this is not a good sign, and this is not a good thing, because of this one we can damage our objects, or the iron objects can be damaged because of the rusting. So here we can see after some times what will happen, the more rust will be there, and ultimately these cannot be used anymore when we have to replace the things. So these things happens in our homes, we know that thing, and this is when the iron reacts with the water vapor present in the atmosphere and the oxygen present in the atmosphere. When it reacts with both the things, when the iron reacts with both these things, the rust is formed, and these things cannot be changed in the previous form. We cannot, by any means we cannot change it to the previous form or the form that we have used. So here by any form we cannot get into this form. If we rub it with the help of sandpaper, we may get, but there will be some loss in the mass of this object. So there is some changes are taking place, and if more rust, then it is not possible to obtain the previous form. So it is also one example of a chemical change, because things will not be able to obtained by after this type of reaction, or after this type of changes things cannot be obtained. So it is that is chemical change. So these things, how can we prevent the iron objects, because we use iron mostly, so how can we prevent these things permanently? So some temporary methods are there, like for a few years we can use these things, like if we paint the object. So if we paint the object, then the objects can be prevented from getting rusted for few years. And permanently, how can do it? So you have seen some poles, probably you have seen these poles, and these poles are of iron, but they are little different iron. They are not like normal iron, and you can observe that these iron poles do not get rusted easily, because they are no galvanized iron. So this is little different. So electric pole is there, and here what happens, the iron is coated with zinc. So zinc is another metal which is given, or a coat of the zinc is given on the top of the iron, and when it is done in the industries, this is known as galvanized iron. So this the process is known as galvanization, where the coat of the zinc, as thin layer or thin coat of the zinc is given on the top of the iron, and it is known as galvanization. And the iron which is obtained after the galvanization process is known as galvanized iron. Here you can see here also these are known as galvanized iron, and here you easily they don't get rusted, and there we can use these things for permanently. They will not get rusted easily if it is left on the open places, and we don't need to paint it also. Paint is also not needed in this galvanized iron or GI pipe. So you probably have heard the term GI pipe and all. GI means galvanized iron. Okay. Then another process is that crystallization. So what is crystallization? So crystallization means the process by which the crystals are formed from the from solutions or gas or any form of, mostly from the solutions or from the liquid. If crystals are formed, then this process is known as crystallization. So what are crystals? Crystals are like these objects. So these are known as crystals. So crystallization, how it is done? So if you have a solution, so there are different methods or different processes are there to obtain the crystals. So one now is there in your book, and another here I have explained. So here consider you have a solution of one solid, you have a solid substance, and you have the solution of that solid substance. Consider you have the copper sulphate solution, and in that copper sulphate you have solution of you have the solid, that is copper sulphate, and along with that some insoluble impurity may be there, like some dust particles and some other things may be there. So these are known as insoluble impurity, and along with that one we have the solution of one solid. And if you evaporate the things, if you filter the thing, firstly we have to follow some steps, and first we will filter it with the help of filter paper, and we'll collect the solution in evaporating dish, where we can evaporate the thing and evaporate to reduce volume of solution. So when we will evaporate, what will happen? The excess water that is present in the solution will evaporate out, and we can transfer this hot liquid to a dish, and if we leave it for sometimes undisturbed or until it is get cooled, what will happen? The solution is saturated, and from that one we can obtain the crystals. So when it will be cooled down, we can obtain the crystals. So this is one process. Another process which is given in your book, that when we will take a beaker or any evaporating dish, and here we'll take some water, and in that one we'll take some dilute sulfuric acid, or we can directly take some dilute sulfuric acid in a beaker, and in that one we'll start boiling it. We'll start boiling the dilute sulfuric acid, and we will start adding the copper sulphate powder in there. So normally we get the copper sulphate powder. How we will convert it to crystals? We will take some sulfuric acid, dilute sulfuric acid in a beaker, and we will start boiling it. When it will gets boiled, we will be adding the powder of that copper sulphate powder to that, and we will be continuously stirring this. So once the solution is saturated, means no more copper sulphate powder is getting dissolved in the solution, we will stop adding, and we will leave it for cooling. So once it gets cool, what will happen? We can get the crystals from that. So if you don't get that, we will wait for some more time to get it more cool. So after that we can obtain the crystals from that, and that will be the process and that process is known as crystallization. So these things are practical things that should be done in the practical labs, but we are doing the virtual classes, and so I hope you have understood the little concept of crystallization. And if you have any kind of confusion or anything, you can ask me, and I am here to help you. And thank you for watching the video.